Okay, 8.1, equations of a line in two space. Alright, so this is for the calculus crew. We're looking at equation of a line in two space. In example 1, given a point 1, 2 and a slope 3/2, find the equation of the line. Now, in standard form and slope-intercept form. Now, normally, when we look at questions in this unit, or questions like this would be something you've already done in grade 9 in your freshman year. What we're looking at is we're going to how to apply this information in something where we can find the equation of a line, not just in two space, but in three space as well. So the two types of equations we're going to be introduced to are called vector's equation of a line, and the vector equation of a line is as follows. If you're given a point and a vector, so a direction vector M, and once you're given the direction vector and the point, the vector equation of a line is as follows. xy is equal to a1, a2 plus t times m1, m2, where t is some real number and t is a parameter. So that I could find any point on the line as long as I know my point and the part of the direction vector. I would just need to plug in a number. So we're going to look at examples of this throughout this course. So normally in grade 9, this is what we did, folks. We subbed in m equals 3/2 and 1/2 for xy into the equation. Now we use the grade 12 equation, y minus y1 equals m times x minus x1, and plug in the point x1 and y1 in there, and we plug in m, and once we do that, to find standard form, we multiply everything out by 2 and expand, and we find the value in standard form. In y equals mx plus b, folks, we have y equals 3/2 x plus a half. Where did we get that? We isolated for y. Now what we're going to learn to do is make the equation look something like this. So we're going to be able to convert all lines to vector equation of a line. The other type of equation of a line is something called the parametric equation of a line. A parametric equation of a line is going to be as follows. If you're given a point A1, A2 as a fixed point on the line and a direction vector M, M1, M2, and that's the direction vector, the parametric equations of the line are x equals a1 plus t times m1 and y equals a2 plus t times m2, where t again is a real number that is known as a parameter. Now, the difference between a vector equation and parametric is one is where it's all vectors set up as a vector, x and y together, and parametric, x is separated from the y. Note that the vector equations of a line and the parametric equations of a line do not use slope. By using a direction vector, these concepts can be used in R3 as well as R2, so in 3 space as well as in 2 space, whereas the old way of doing a finding equation of a line can only be used in 2 space type of questions. So we're going to look at some examples that go with this. All right. Example number 2, you're given A is -3, 4, and B is 5, 3. You're asked to find the equation of the line in vector and parametric form. So, how are we going to do that? Well, first you need the direction vector. The direction vector is basically find the vector AB, and that's going to be 8, -1. And you know the vector form is going to be, pick a point, let's say -3, 4, and we find this point, and then the parametric form, it's going to be this way. Now, Why is that the case? Let's go over this again. We're finding the vector from A to B. A is going to be our fixed point. So from the direction from A to B is going to be B minus A. Remember to find the direction vector. So it turns out to be 8, -1. The vector form, xy as your vector, is equal to the fixed point plus t is the parameter times the direction vector, 8, -1. The parametric form that you see here is basically x separated from the y. So x is equal to -3 plus 8t. That's where this came from. Y is equal to 4 plus -t, which is 4 minus t. And those are your two values for parametric form. Now, example 3, you're asked to state the equation of the line in parametric form that is perpendicular to this particular vector equation and passing through this particular point. So we need to know the equation of a line that is in parametric form that's perpendicular to this and passes through this point. So that's our fixed point right there. Okay, so our direction vector is what's going to be important. What does it mean when it says perpendicular? It has something to do with this direction vector. Remember that this is delta y and this is delta x. So delta y over delta x is our slope. If we want the perpendicular version of it, that would mean that the slope changes. The original slope is 3, 5. The perpendicular slope will switch the x and the y and make one of those values negative. It doesn't matter which one you do. And don't forget, if you want to check it, remember that the dot product of two vectors that are perpendicular will be is 0. So we can take the dot product and check that it equals 0. Ultimately, what we have to do now is find the equation. The equation is using the fixed point. xy is equal to the fixed point plus t times -5, 3. And it says find the equation in parametric form. So we take vector form and convert it to parametric form. All right, it's much easier to go from vector to parametric just so that to be able to find our final solution. All right, folks, that's the end of that example. One more to look at, example 4. You're asked to state the equation of the line in vector form that is parallel to x equals 9 minus 3t, y equals -2 plus 4t, where t belongs to real, and has the same y-intercept as this vector equation. All right, where t belongs to real, and that's the end of it. Okay, so how are we going to find the equation of that line? Well, we know it's parallel to this, so that means if it's parallel, they share the same direction vector. Okay, so parallel, in the first question, we can find the direction vector. The direction vector is going to be -3, 4. The parallel direction vector is also going to be -3, 4. And our fixed point is going to be the point that's the y-intercept. What makes a y-intercept here? Well, x has to equal 0. So if we put it into parametric form, what we can do is set x equals 0, find the t value that makes x equal 0, and plug that t value in for y to find our y value. It turns out our y value is -3, 5, -3 over 5. So finally, our vector form equation is going to be 0, -3, 5. That is our fixed point, plus t times -3, 4. And that is our direction vector. So this is our point, and this is our direction vector. Okay, well, that's the end of the idea of how to find the equation of a line in vector equation and in parametric equation. Have a numerical day.